Okay, hello. Today we're going to talk about operating systems. Since I could not record the videos in the auditorium, I'll try to make some videos offline for those who missed the class. So far Diego has been talking about the architecture level, and I'm going to talk about the operating system level. So if you've seen this diagram in Diego's lectures before, you'll see that sometimes we define the operating system to be at this level, which is above the architectural level captured down there. Right. And now we'll see how the details of this. In particular, operating systems rely on the architecture support, at least in the modern computers. This was not always the case, but as systems evolved, operating systems have relied more and more on hardware support. So nowadays, in a modern system, hardware support is essential for most of the things that operating systems do. And we're going to look at the details of this in a moment. But before, let's quickly talk about the history. So in the early days of computing, people did not really have a notion of operating system. In particular, back in the day, the computers were few, and if there were only few machines, there were only few people who were using them. And in particular, you would have a big machine that somebody had a computational problem. They needed to compute, say, logarithm tables. They would write a program, feed it to the machine will do the calculations, and then print out some output. But as computers and programs both started to evolve, people realized that there are lots of common tasks that all these programs do. For example, all the programs needed a way to print or to read their input or do some menial task that is not their focus. And then they realized that they could have a program running in the machine all the time to take care of these common services, or to provide these services to all the programs. And that's how operating system started to evolve. They started from very small programs that were doing a few things to clean up after themselves and to load the next program. And nowadays, they are very complicated softwares. So a modern operating system does a lot of different things. For example, it manages processes, threads, and scheduling. It manages storage. It manages different types of input and outputs, for example, writing and reading from the terminal. It manages a memory. A modern operating system will allow multiple users to use it. And it also implements different parts of networking, and in particular because networking is also part of input and output. And in general, it provides many different common services that programs use. In general, the operating system resembles a library. It provides an interface and services for other programs. If you want to read a file, you ask an operating system to do it for you. But it is also different from a normal library, and we're going to get to it in a moment. In particular, the OS is a software program that is privileged by the hardware. What this means is that it can do things that a normal program cannot do it. There is a huge section of any modern system that is off limits to any normal program. And the operating system is the only program that can access those features and those essentially services or those systems. I'm going to quickly in a moment show you in some examples of what operating systems do. So I have some screenshots here. So if you log in Linux and if you type ps-e, you will see a long list of processes that are running. So you'll see that your Linux machine has tens or maybe hundreds of processes running at the same time. Most of them are sleeping and not doing much CPU or not using much CPU time, but they are still around. So it can do multiple processes. You can also see that you can have multiple users logged into your system. Back in the day when we had actually servers where you could log in, press W or type in W, and it would show you all the other users that are logged in at the same time with you. Operating system also do memory management. We will look at this later on, but if you type a pmap command in Linux followed by a process ID, you will see the summary layout of this program in memory, the different section of the memory this program uses, and all of this is set up by Linux. So the operating system is also in charge of this. Okay. And as I mentioned earlier, operating system do these tasks using system calls, and system calls, you can think of it for the moment as similar to a function call. If you want to do something, we set up the parameters, we pass it to the library, and the library does it for us. For now, we can think of it this way. So in this example over here, what we have is the write system call. And what we're doing here is we want to write this message to the terminal. So in Linux, the terminal is abstracted as a file, so we use this system call to write to this abstract file, and therefore it gets printed to the screen. And finally, to exit, we also do another system call to exit. Okay. So this is, I guess, the ARM equivalent of the printing message that we had. So this is an example from hardware. If you want to type or print out the message in ARM, you do the same thing. But now the only difference here that our system call instruction is now called SWI. Okay. So in the rest of this lecture and video, I'm going to talk about the following, or the objective will be the following. We should be able to name a few things that the operating systems do. We should have some basic understanding of how those things could be possibly be done. We're not going to look at the details of how those things are done. That will require a much longer lecture and a full-on OS course. But we at least should be able to say how it is possible to do those things. We'll also see an example of different philosophies when it comes to design of the operating systems, and also how architecture and operating system interact with each other, and how the design of the hardware or operating system is influenced by, or design of these things influenced by each other. And I'll also show you some examples, some fun programs in Linux that uses system calls. Okay. The overview of the remainder of this talk is basically going to be the following. I'm going to talk quickly about privileges and protection systems that exist in modern systems and the operating system exploited. We're going to briefly get exposed to system calls. We're going to spend quite a bit of time on virtual memory and how memory management is done. And then I'm going to show you examples of different system calls and how operating systems basically work, or different operating system architectures work.